The left example, this example. There's so many good examples for the there's a key point I want to talk about. It's very nice. The left example.
Okay, now we going on. So now first of all, you treat, right? First of all, you treat the system as one object. And after that, you want to find out the internal forces. You can break them into as the separate object, right?
Yeah, true.
Okay. So that's why here we are talking about the application of the second law of Newton, right? For the
There's also a really good example for the elevator.
Yeah. So any applicator here, you know that the diagram here show you that the stationary helicopter is raising two people. So that's why you need to find out the tension.
Keep in mind that the helicopter is still moving, so you can't calculate this way.
Yeah. So if you want to be a pilot in the future, you know how to exert the force to maintain, right, the velocity.
You crash.
Okay, now look at this one, for example.
Yes.
So example here, we show you more kind of the motion. Now, snowmobile, right? You know, snowmobile are in here. You have the mass of 300 kilogram, and also their mass is a 75 kilogram. Here, look at this one. They already know enough any resistance to motion, right? That means without resistance.
This is ice.
Yeah.
Yeah.
So now diagram the showing the forces on a snowmobile include our view and the object now. So that's why for each one you must to show the forces.
There's this tension between this part, and there's a bit of tension between the ice. But then we ignore the resistance. So here.
So reaction force on our view also.
Yeah, but you have to ignore resistance too. I mean, yeah, we should add. Does he move up? That's my question. Does he move up?
Okay. So now you can see here for each one, right? Look at this one for each one. That's mean for the area, you can see reaction and the gravity and the tension, the purple, right?
Yeah.
Right. On the background, only the forces vertically exist on the background, right? Acting on the background.
Just tension
and the gravity also.
Yeah.
Okay. So now it depends on the given information. It depends on given information. If you have, look at this one, you write down for R view, right? We have D minus T equal to mass times acceleration, because we know already the mass and also acceleration, right? Here, they're given that upward acceleration, 0.5. Okay?
Yeah.
So that's why the Arvin and the Begna go with the same acceleration. Okay?
Yeah.
So that's why you have here D minus T equal 150. And also you can write the second law of Newton for the Begna. Similarly, you have a T minus gravity here, 75 times G equal to 75 times acceleration. And then in this case, for the second one, you can find out the value of T and substitute for the first one, you can find out the D. Okay?
Yep.
Got it?
Yep.
Okay.
You just insert and then you
So now for the third one, it depends on the initial value U equal to 0, V equal to 5, and A equal to 0.5, and T is required. Right?
Yeah.
And by using Suvat, you can find out the T time.
Yeah.
You know, when you use the forces, you want to calculate the forces, you can use the second law of Newton. If you want to connect, that means to find out relationship between the velocity, time, and distance, and so on. You must using the Suvat, right?
Yeah.
Okay. By using a second law of Newton, if you're given the forces, you can find out the acceleration. And after that, next step, you know acceleration, and combined with the Suvat equation, you can find out the distance, speed, and so on. You know, step by step.
I mean, you can. There's also much more to associate, but I mean, yeah, I can associate them.
Okay. So now, if you have a time, you can find out distance, because Suvat you have ut plus a half of at squared.
Correlation with the distance and the relation.
Okay, right. So that's correct. So you got it. So maybe you can find out distance by using the shortened formula. V squared equal to U squared plus 2AS, right? Okay, now here you go. Yeah. Move on the next one. Okay. So if you understand this one, for example, and everything you can do with example 4.5, here, look at this one. I will show you the example. Here, you know, for example, the woman, here you can see that they have two kind of the forces: reaction force, gravity, right? That's all. But you know the floor, but you know the floor will go with the acceleration A vertically, go upwards, right? Now the positive is upwards. So now you can see so the second law of Newton for the woman here, you know, reaction force minus gravity 60G equal to 60A, okay? Okay.
Yeah.
So now look at this one. If the woman on the floor here go with the constant speed, that means acceleration is 0, right? So reaction force will be the gravity. Okay.
Okay.
So now, if you want to go, maybe you can enter the building, right? So it depends on the quality. That means qualification of the building. You can see that if you go up with acceleration, so it means you will take some reaction force, right? You can feel this one, but randomly, so the building with the high quality, that means the qualified. So see, if you see that the lift will go, that means constantly, right? You go constantly. That means the people inside the lift cannot feel any train. Okay.
Yeah.
So that's better.
That's a good quality. But then there's the one that, like when you move,
that's right.
you can feel like a sudden, like when you
Yeah.
stop at level.
Yeah, that's good stop, like some guy break, right?
Yeah.
Okay. So now you can understand well now. When the constant speed is a zeros, so that means reaction force equals to the weight, right? Normal reaction force here. If the acceleration is 2, that means go up, increasing velocity.
Okay.
You see that the normal reaction force is 720 Newton, greater than when the A equals 0.
Normal reaction.
Right? And you can feel it heavier. You got it?
Yeah.
When the lift go up, increasing speed, you can feel you're heavier. Right.
Oh yeah, because you're pulled more to the ground. You have feeling. I remember when you go up, you feel like you're pulling down.
Yeah, that's right.
When you go down, you feel like you're floating.
Yeah. You go down, you can feel that
you're floating for some reason.
Yeah.
Because of this.
Yeah.
It's interesting.
Yeah, that's right. So that's why now I'm want to. So now this is why I want to explain for you clearly here, right? So now if you acceleration is downwards, right? I equal -2. So you see here, normal reaction here, there's 480 Newton, that's all. Okay. So we can conclude that the leaf is moving downwards and slowing down. The acceleration is a negative downwards, so it's a positive upward. Right. And then if now if the leaf there were n passengers, right? So now the combined mass of this one, you can take the 300 kilogram times the number of passengers multiplied by their weight.
Yeah.
Okay. You got it?
Yeah.
For suppose here we have n passengers. Okay. So now gravity force will be 300 plus 75 n times g. But the tension T here, you can write down the second law of Newton. Second law of Newton here, T minus 375 n times g equal to the 300 plus 70 n times a. Because here we treat the system, the own people here, and the leaf as object, right? With the mass of 300 plus 75 n. Got it? So now, if given the acceleration A is 3, G is 10, you can find out the tension depend on the number of passengers. Okay. So now, for the maximum tension, right? That means to keep maintain, they can hold the lift, right? The maximum 12,000 Newton. So that means the T here, look at this one, the formula of T here must be equal to 2,000, smaller than or equal to 12,000. Okay.
But I don't think 2,000.
Okay. For the maximum number n, you can make the equality here, and then after that, you can find out n. But n the number of passengers just means that there must be positive integers. Okay.
Yeah.
Okay. So in this case here, you can find out n equal to 8.31. So that means the maximum, yeah, the lift carry about 8 passengers. Got it? Got it? Okay. So that means you understand well the mechanic here, and then you can apply it to the lift. And when you enter the building, you can see the maximum number of passengers they write down inside the lift.
Yeah,
You
yeah,
see
yeah.
that?
They also even write like kilograms, how many max kilogram, or because sometimes the lift is operated for like carry the luggages, that can contain lot. They also write the amount of maximum kilograms.
Yeah, maximum kilogram is better.
Yeah, because
And after that they can calculate by divided by the average weight, right? And you can find out the number of passengers.
Yeah, but like it's suggested that you should use kilograms or else like
program is better, but you know, for each one don't care about kilogram, they just count only the number of people. Right?
Yeah.
So that's why scientifically you write the weight, the total weight, but in your real life they don't care this one, they care about the number of people, that's all.
Yeah, okay, I understand.
Okay,
but
you
there's
got
also more things to worry about, just unlike just like the weight, because the rope also has some tension to worry about, the maximum tension for the rope that's carrying the
that means the maximum of the rope, just mean up, if you can exceed the tension exceeds this one, just means the break the lift, and the lift will falling freely.
Yeah, and then like everybody will die. It's possible, like you shouldn't. There's obviously attention to it. I mean, I haven't been in a situation where like the rope can cut, but like it's possible.
Yeah.
Like you free fall.
Yeah.
And like
Free falling for all.
Yeah, and also nobody can control it, so you can hit the sideways.
No. Free falling, that means no control. Impossible to
control. So you hit like the ceiling, like the
it hit the ceiling. That means
and the walls.
They will die. They will die because they collide with the ceiling of the lift. Okay. So what is this phenomenon? So this very interesting, right?
Yes, very interesting. Very day-to-day life.
And also here you can feel the mass. You can feel the weight trend, but you know the mass is constant, right? The mass always the same, but the weight, you can trend the weight. You remember this one?
Yep.
For example, you have 50 kilogram, for example, here. 50 kilogram here on the earth, the weight will be 500 Newton, right? But you have the same 50 kilogram on the moon, right? The weight will divided by 6 times, right? 500 divided by 6.
Yep.
You got it?
Yeah.
Okay. So now, example 4.6 is very interesting on. So look at this one. Now you have two particles A and B. The mass is 0.6 and 0.4 respectively. You know why we have to train the value of masses of particle? They must be different. You know that? Why?
The mass or else
the masses of two particles, they must be different.
Or else they just balance out each other.
Yeah, because they want to describe the motion with acceleration, right?
Or else the distance, yeah.
Yeah. So if the two mass is the same one, so you have no motion. Okay. Okay. They are stationary.
Super minus that also super 2. Super 2 is the kind of the force. Two.
So now look at this one. A line in extensive string. A line intensive string just means when A go with the distance x and B also go to the same distance, right? And in a line string, so that means the tension exists on A is the same the tension exists on B. Okay.
Yep. Yeah.
So now find acceleration of system.
Tension on the string. The acceleration is kind of upwards. For this guy, it's upwards. But for this guy, for B, it's downwards.
Downward. No,
I mean, like, these
B
for
upward.
downwards. What?
No,
Upwards?
A downward and B upward.
Wait.
Because A is the 0.6 kilogram. The weight heavier than the B.
Wait. Oh no. Yeah,
Got it?
I misread the problem. So yeah, it's like it's not bad.
And A go down and B go up. Okay.
And yeah, and the tension of the string is
So now how to find out the acceleration of system?
acceleration of system.
Yeah, how to find out acceleration of system?
We will need to find one A like one wouldn't A cancel out B because it's heavier. This acceleration will be larger than B's acceleration.
No, the same acceleration. The same acceleration.
But like just now you said that like B's yeah, technically true because yeah, this seems acceleration. It's just that actually, yeah, from A's point of view, we're going down. So that since this is a pulley, yeah, this is kind of I don't know, pulley, it goes up. So we take an A acceleration. So A and S minus 2.
No, so you can write down the second law of Newton for each one.
Yeah.
You can figure out the forces for each one. First step, draw diagram of the forces on each one object right now.
Sure.
And then the next step, you write out the second law of Newton for each object.
So I drawn the diagram. Do I just like mark out all the forces? Okay.
Here, first of all, you must. Yeah.
This is let me. This 0.6 kg going downwards. There is a going downwards. This one is 0.4 kg going downwards. So I mean, it's not the picture. 0.6 kg. There should be from the center of the object, not from. Yeah, somewhat. I don't know how to do it. Like, there should be a scale. There is a scale.
So moving out clearly the forces and the weight here. This one.
Yeah. Well, how
and
do you get
then
the arrows?
and then here the tension, and here the tension.
There's somewhat
The same one, and also here the weight, right? And after that, you can write down for second law of Newton of each one. So here, look at this one. Separate process for the A. Now you have a 6 minus T for the A. Here, look at this one. 6 here minus T here, right? Equal to 0.6A. So that's the first equation here.
Got it.
And the particle B, you know, T go up. So T minus 4 equal to 0.4 times A. Here's the second one. And after that, you can solve the system of equation here. You can find out the value of acceleration A is 2. And when you find out the value of A, you can substitute by substituting here for the first or the second to the first or to second equation. You can find out the T. Here the T. You got the answer?
Yeah. I got it. Yeah. Yeah.
So now I tell you that by using the second law of Newton first of all, you can clearly figure out the value of forces and the value of acceleration. And after that, you have the acceleration. You can find out the velocity and the distance and so on by using the Suvat equation. Suvat formula. Remember that?
Yep.
Okay. After the second law of Newton here, and then you can here you can see now by using the Suvat. If you know the distance, right? You know the distance. You know the acceleration. You know the time, and then you can figure out the distance here.
It's just two,
right?
It's the same.
Yeah.
Yeah.
So that means you can find out the distance. Okay. And the particle move down 4 meters. The particle B move up 4 meters also. And when the string is cut, right? If string is cut, so that means the particle A go down 1 meter more, right? And particle B is to go up, right?
Yep.
The 4 meters above the ground. Okay. You got it? The situation?
Yep. Yes.
Okay. So now I think that this part will help you to understand well the system of equation. Now I remind you that the first step, you draw diagram of forces. Okay. The second step, you write down for me the second law of Newton for all objects. If you have a 2 objects, you must write down the 2 second law of Newton.
F equals ma.
Yeah, and then after that, solving by you can solve system of equation. No, solve system equation to find out the acceleration and the forces. Right? And after that, by using the Suvat formula, right, you can find out the related quantity like speed, distance, and time, so on.
Acceleration.
Yeah, that's all. So you got it?
Yep.
You have any question about this one?
No.
Okay, fine, great. So now for you, you practice, for me, the exercise 4C. The 4C here we have 1, 2, 3, 4, 5, 6 here. You know this kind of the will describe this one for the single one. And I you know, as a previous example, I explained for you, right? And then here, the 7 here, you can analyze the graph, right? Understand well each part, each line will be corresponding motion, okay? And then this one, because because here is the last one of the part of this chapter. So that's why you will do with the some kind of the exercise taken from the Cambridge A level past paper. You see that?
Yeah.
Yes. So this is why you know that the way we do together just means, first of all, you understand well the basic knowledge, right? The second one, you understand the examples, right? I explained for you everything clearly. And after that, the sum apply, that means the sum apply question. You can apply the formula, the theory, the second law of Newton, and the Suvat formula to find out the missing or the unknown quantity, right?
Yeah.
So that's perfect here. The key point, the equation of motion here, the resultant force equal the product of the mass and acceleration, right? You can write now F equal to M times A.
Sigma F, not just F, sigma. I mean, technically, it's resultant.
Yeah, resultant force, that means F here, the sum of all forces, external forces. Remember, external forces, right?
Yep.
Okay. And the connected object, and I told you that you can consider the system of object as an object, right? Yep. And after that, you can do, you can treat with them separate object by using the second law of Newton for each object one. Okay.
Yep.
So now this part is a finish for the chapter number 4. So this chapter number 4 is a very important role for the mechanic one. And you know that now you understand well the phenomenon. When you enter the lift and you enter the bus or anything, yep, you can understand well everything will happen. You yep. can explain all of them. Yep. Before you cannot, right? Before you cannot know why the train is heavier or the lifter, right? But now you understand well why you can feel, okay, my weight may be heavier than the normal, right? Yep. Okay. So I think that this key point will stop here for this chapter number 4. And the next time we make more complicated for the vector to have this, the factor here is a chapter of the mathematics. But yep. in the mechanic, you need the mathematics a lot. You can apply a lot of mathematics in the physics and mechanics also. Got it. Yeah, with math you cannot follow the physics. With math you cannot follow the mechanics, right? Yep. Yep. Okay. So now I think that we can stop for today. This one. And remember that if you prepare the homework before, yep, I can help you a lot, because I will correct that. Just not only the answer, the final answer, but I want to explain for the phenomenal, physics phenomenon for you. Yeah. Okay, here we go. Now you have a time of break, the winter break already. Yeah. Okay, fine. Okay, try the best. If you have more time, focus on AMC, right? Yep. Okay, fine.